OpenAI, Google, and Meta aren't actually racing to build smarter AI. They're racing to build cheaper power plants. And once you see this, you can't unsee it. The real bottleneck in AI right now isn't intelligence. It's electricity. Let me explain why this matters to you, and why the companies won't say it out loud. First, the scale. Training a single large language model like GPT-4 takes about 50,000 megawatt hours of electricity. That's roughly what a small town uses in a year. Inference, running the model once to answer your question, takes less, but multiply it by billions of queries per day across millions of users, and you're looking at the energy footprint of a small country. Google's AI operations alone now account for a noticeable chunk of their total power consumption, and it's growing exponentially. This isn't a side cost. This is the cost. Here's where it gets interesting. In 2023 and 2024, every major AI lab started doing something unusual. They stopped talking about model size and started talking about data centers. OpenAI signed power deals. Google bought land next to nuclear plants. Meta started building custom chips not to make AI smarter, but to make it more energy efficient. Anthropic, the newer player, literally factored power availability into where they'd set up shop. These aren't R&D decisions. These are real estate and infrastructure decisions. The reason they won't say this directly is because it kills the narrative. The story they want you to believe is that AI companies are locked in a pure intelligence race, that whoever builds the biggest, smartest model wins. That's exciting. That's venture capital friendly. That's sci-fi. But the actual race is logistical and physical. It's about who can secure the most reliable, cheapest electricity. And that's boring. It's about power grids, not brainpower. But here's what makes this crucial for you to understand. If energy is the real constraint, then everything changes about how AI will develop. It means the companies with the best access to cheap, renewable power, whether that's nuclear plants, hydroelectric dams, or geothermal sites, will have an unfair advantage. It means AI progress won't be limited by how smart engineers are. It'll be limited by how much electricity is available. And it means the next breakthroughs in AI might not come from Silicon Valley. They might come from wherever the power is cheapest. Let's zoom in on why this happened. For years, the assumption was that you could just keep scaling up models. Bigger model equals smarter model. Throw more compute at it. But somewhere around 2022, the economics flipped. The cost to train the next generation of models started rising faster than the capability gains. You hit diminishing returns. So what do? You don't build a bigger model. You build a more efficient one. You optimize for energy per unit of intelligence. That's why the chip wars matter so much right now. NVIDIA has dominated because their GPUs are powerful, sure, but also because they're the known quantity. But now Google's TPUs, Meta's custom chips, and even startups are designing silicon specifically to reduce power draw. This is the real competition. Not who has the smartest PhD. Who has the chip that uses the least watts per inference. It's engineering, not inspiration. And here's the kicker. This is already affecting which companies can compete. A startup can't compete with OpenAI on raw brainpower anymore. That's too expensive and requires too many people. But a startup with access to cheap power and a clever algorithm? That's possible. That changes the whole landscape. It means the moat around the big labs isn't their talent. It's their electricity contracts. Look at what's happening with AI in developing countries. Why would a company in India or Southeast Asia build their own AI model when OpenAI already exists? Because electricity is cheaper there. Because they can afford to run larger models on less money. This is already happening. Local AI models are emerging not because they're better, but because they're economically viable given local power costs. Now, you might be thinking, okay, but does this actually change what AI can do? And the answer is yes, in a weird way. If you're constrained by power, you have to be smarter about how you use it. You can't just brute force your way to better results. You have to think about efficiency. And sometimes, constraints breed innovation. So the companies with the tightest power budgets might actually end up building the most elegant, efficient systems. Scarcity forces cleverness. There's also a geopolitical angle here that almost nobody talks about. Countries that control cheap energy sources, whether that's oil, natural gas, hydroelectric capacity, or uranium, now have leverage over AI development. A country sitting on geothermal resources has a strategic advantage. This is why China has invested so heavily in AI infrastructure in provinces with cheap hydroelectric power. It's not an accident. It's strategy. So what does this mean for the future? Well, if energy is the real constraint, then the bottleneck for AI won't be solved by better algorithms or smarter people. It'll be solved by fusion energy, by massive renewable build-outs, or by fundamentally different computing paradigms. We're not waiting for the next genius. We're waiting for the grid to catch up. And that's a decades-long problem, not a 5-year problem. This also explains why you're seeing so much weird energy news and AI coverage. Why is OpenAI buying power plants? Why is Google trying to revive nuclear? Why is Meta obsessed with chip efficiency? It's not because they suddenly care about the environment. It's because they have to. Energy is the constraint. Everything else is downstream. The uncomfortable truth is that the AI revolution will move as fast as the power grid lets it, not faster. And right now, the power grid is the limiting factor. The companies know it. The investors know it. But they can't say it too loud because it makes the whole thing sound like a boring infrastructure problem instead of a world-changing technology problem. But that's exactly what it is. If you want to actually understand what's happening in AI beyond the hype, this is the lens to look through. Stop asking if a new model is smarter. Start asking where it's being trained and what's powering it. That tells you way more about the future than any benchmark score. If you want to keep up with these kinds of non-obvious AI stories that actually matter, subscribe. I break down the real dynamics behind the headlines every few days, and this stuff doesn't make it to mainstream coverage.